Hello everyone and welcome to Science Vlog number 1, the very first one that we're going to do. And today we're covering the topic, since it's winter, a lot of northern countries are so cold. I'm sure people are wondering, what happened to this climate change thing? What's going on with that? So today we're going to cover climate change. We're going to talk about our atmosphere a little bit, why gases are important to our atmosphere. Why is climate change important? What does that even mean? Why did we switch from saying global warming to climate change? That's a big thing that's talked about a lot. And then, most importantly, what are some of the consequences that we're seeing right now? But what can we do to help fix and be part of the solution to some of the environmental issues that we're seeing in our world? I hope you're excited as I am for this first science vlog, climate change. That's vlog number 1. So let's get right into it. If I was to ask, what is the hottest planet in our solar system? A lot of people might say Mercury, because Mercury is the planet closest to the sun, thereby it's the hottest. But actually, Venus, the second planet from the sun, is the hottest planet. That is because of its atmosphere. Atmosphere is what matters in making a planet hot or cold, as well as the distance to the sun. So, Venus is actually composed of almost 97% carbon dioxide, only 3% nitrogen, and other gases fall. But it's over 95% carbon dioxide. Whereas Earth, our atmosphere, is 78% nitrogen, 21% oxygen, and other gases fall into that last 1%. I think our carbon dioxide total in our atmosphere is 0.03% carbon dioxide. But it's important. That carbon dioxide is very important because it's a greenhouse gas. And it's very important in keeping our planet warm because we are further from the sun than some of the other planets. So what do we mean by greenhouse gas? We hear that put out a lot. So a greenhouse is essentially a glass building that people build in especially northern countries and northern regions so they can grow plants year-round. So a greenhouse principle is rather simple. It's a glass sort of shed. Sunlight can go through the greenhouse, go through all the glass, but when the sunlight and the heat then reflects off the surface of the earth and bounces back up, it's reflected back in by all the glass. It's a principle known as the greenhouse effect. So, and I'll put a graphic and make sure to show you what the greenhouse effect looks like so you can see it with your eyes and picture it. But it's this reflective nature of things, of the sun's light able to penetrate through something and then be reflected back, so the heat is retained. The heat is retained by the system. So carbon dioxide, very important greenhouse gas, is we don't have panes of glass in the Earth's upper atmosphere to keep our heat in. We have these gases in our atmosphere, the nitrogen, the oxygen, the carbon dioxide, etc. But these gases all sort of behave differently when it comes to their degree of reflecting that sunlight back towards the Earth. Nitrogen's it absorbs a lot. It can just take it and not be entirely very reflective. So I sort of picture nitrogen like a big pillow. You can punch the pillow, you can hit the pillow, but you're never worried about your fist coming back and recoiling away. You don't bounce off a pillow per se. Carbon dioxide, on the other hand, because of how its bonds form, it can stretch, it can reflect. It's very reflective molecule. So I sort of think, rather than a cushion, carbon dioxide is like a trampoline. It's very stretchy and things bounce off it very easily. That is carbon dioxide in essence. So our carbon dioxide in our atmosphere is very, very important, reflecting that heat back to us. And that brings me to the next very important point, is the difference between heat and temperature. We use them interchangeably sometimes in our everyday life, but scientifically, there's a difference between temperature and heat. Temperature can be measured in Fahrenheit, Celsius, or scientifically in Kelvin. Most people don't know that Kelvin is a way of measuring temperature, but it is. It's a very important one, actually. But those are measurements of temperature. Heat is an energy measurement of energy. So its unit is not Fahrenheit or Celsius or Kelvin, it's joules or kilojoules or kilocalories or calories. It's a measurement of energy. So heat doesn't necessarily always mean temperature. So if you have an increase in heat, doesn't necessarily mean you're going to have an increase in temperature. Not always necessarily, and not interchangeable with each other. So when we're talking about these greenhouse gases, they're reflecting not temperature, they're reflecting heat, the joules, the actual heat energy coming from our sun. That's what it's reflecting. And that is what's being absorbed more and more and more in our atmosphere. That is what is being reflecting as we increase the amount of carbon dioxide in our atmosphere. And when we have this global warming now versus climate change, it sort of gets at this, because global warming, you think of something getting warmer, we're only thinking about temperature, really. We're only covering the temperature effects in that statement. And what scientists realized eventually was that that's sort of limited. It's very limited in its regard. So what they did is they said climate change, because heat affects so much more than day-to-day temperatures or temperature trends. Heat affects a lot more than that. Extreme weather events, all of these things, our oceans, everything, our climate, cold fronts, everything will be affected by this increase of carbon dioxide and fossil fuels and these greenhouse gases in our atmosphere. These are all are seeming to have an effect on our climate overall, and that's why it's given the total name of climate change. And we see these effects, unfortunately, already on some of our wildlife, especially here in Florida, well, where I live. I'm fortunate to be going to university down in South Florida, doing my PhD, as I said in my first video. And I was fortunate enough to hear about some of the more diverse research going on at my university. It's not just medical and medicine and all of that stuff. There's a lot of ecological, which means the study of our ecosystems. A lot of that research going on at my university as well. And one of it is sea turtle research. It's right near the beach, and there's a lot of sea turtles that come up and nest in Palm Beach County, the areas of beaches where my school is affiliated. And what they've done is that reptiles, the sex determination, so whether they're male or female, is determined by the temperature outside and the temperature of the nest, thereby the temperature of the nest. And what they found is, unfortunately, higher temperatures generate more females, and lower temperatures generate more males. And what they found is that in the past 5 years, there have been no males observed to be hatched from anywhere in Palm Beach County, which is a stretch of almost 5 beaches along the Florida Atlantic coast. No males being born in 5 years. And if we want to see a turtle population continue to be healthy in Florida, because turtles are important for eating jellyfish, they're important for a lot of other ecological reasons, But they need to continue to breed and be a healthy population here in Florida. And unfortunately, because of the extreme temperatures, especially during the nesting seasons for turtles, they see a lot of females. Males are extraordinarily rare to find in that part of Florida, which was not always the case, unfortunately. And then a major event that happened recently that's rather dear to my heart is the flooding in the island of Trinidad and Tobago. I was driving along the coast of Trinidad this past summer, and I saw some of the beautiful coconut plantations. But what was explained to me is a lot of the coconut plantations are being knocked back away from the coast because of the increasing tide. And this is another effect. As the amount of heat energy in our system goes up, our ice caps melt, our ice around the world starts to melt, and this can lead to a steady oceanic sea level rise. And this is best observed in this case in Trinidad, and that Trinidad saw an amazingly treacherous flood that people are still reeling from. And if you want to, I'll leave a link down in the description where people can go support the relief effort in Trinidad. And this is a major part of what can affect humans as a result of that. A lot of island nations might be suffering with these sorts of effects long term, and we don't want to see that happen. We want to make sure that we're all taking care of each other. And lastly, is that in terms of human health, we have a lot of effects that can happen. If I asked what the most dangerous animal on earth is in terms of human fatalities, a lot of people think, oh, maybe a crocodile, maybe a shark, because that's what we're scared of. Maybe spiders, because they sneak in and they can bite you. But no, it's the mosquito. Mosquito is responsible for killing more humans because it is a vector, which means it transmits disease very, very easily. And that is what makes the mosquito so deadly. And mosquitoes overall, they are observed, and I'll leave, of course, all of the journals and everything, all the articles I get my information from down in the description below, and you can see what the mosquito, look at figure 3 of the paper down in the description, and you'll see what mosquitoes, they're slowly starting to increase their prevalency and moving up into more northern regions than what they're accustomed to, and they bring more prevalency of dengue fever, malaria, etc. And it is a big, big issue that we could face long term if we're not careful. So that brings us to my last point. What can we do? What can we do to affect our more healthy environments and create a better environment for our world and preserve and conserve our natural places? And moves to renewable energy are fantastic. Those are really taking off and all of this. But what it comes down to most importantly, I think, is that our rainforests, our local areas, and not just rainforests, because I say rainforest, you think Amazon and Sumatra and these places. Yes, those places are extraordinarily important, and I encourage you to go and support the conservation efforts of those regions. But we have such amazing wildlife, such amazing natural resources in our own places. Here in Florida, we have our Everglades and our pine forests up north. In Canada, the Rouge Park just out of Toronto. We have amazing strongholds of nature, and it is so important that we make sure we support them. We make sure that our voices are being heard to make sure those strongholds of nature in our everyday world are not decimated and cut down. And of course, what we can do is plant, encourage stuff to grow. Try to grow things in your own backyard, and together, over time, with a lot of work and a lot of effort on our part, we can make a difference in our world. And that concludes today's climate change talk. I want to thank you all for listening to Science Vlog number 1. Be kind to others, and remember to be kind to yourself. Have an amazing week, and I'll see you all next week.